In question 1, we have the equation of a curve such that dy dx is 4 upon x minus 3 whole cube for x greater than 3. The curve passes through the point 4, comma 5. We have to find the equation of the curve. Now, to find the equation of the curve, we'll integrate the expression for dy dx. So first, we'll write it as dy is equals to 4 into x minus 3 to the power minus 3 dx. Now integrating both the sides, so this will become y is equals to 4 into x minus 3. We'll increase the power by 1, so this will become a minus 2. Dividing by the new power, so this will be minus 2 plus c. And the derivative of x minus 3 is 1, so we'll just multiply by 1. So y will be equals to minus 2 into x minus 3 to the power minus 2 plus c. To find the value of c, we'll substitute the points 4, comma 5. So this will be 5 equals to minus 2 into 4 minus 3 to the power minus 2 plus c. So 5 is equals to minus 2 into 1 to the power minus 2 plus c. So 1 to the power minus 2 will be 1. So we can say c will be equals to 5 plus 2, which is equals to 7. Now, once we have the value of c, we can just write the final equation as y equals to minus 2 upon x minus 3 whole squared plus 7. In question 2, the coefficient of x power 4 in the expansion of x plus a to the power 6 is p, and the coefficient of x square in the expansion of ax plus 3 to the power 4 is q. It is given that p plus q is equal to 276. We have to find the possible values of the constant a. Now we know that the expansion formula for a plus b to the power n is a to the power n plus n c1 a power n minus 1 b power 1 plus n c2 a power n minus 2 b power 2, and so on. So expanding x plus a to the power 6, we have to find the coefficient of x4. So to get x to the power 4, as in place of a we have x, so we need n minus 2 should be equals to 4. So we will use nc2. In this case, it will be 6c2 x to the power 4, and in place of b we have a, so this will become a to the power 2. So as 6c2 is 15, this will become 15 a squared x to the power 4. So the coefficient of x4 is 15a squared, which is equals to p. So we can say that p is equals to 15a squared. And the expansion of ax plus 3 to the power 4, the coefficient of x square is q. So for x square, we'll get 4c2 ax to the power 4 minus 2, which will be 2, and 3 to the power 2. So this will become 6 into a squared x squared multiplied by 9, which is equals to 54 a squared x squared. As the coefficient of x squared was q, so we can say that q will be equals to 54 a squared. And in the question, it said that p plus q is 276, and we have to find the value of a. So we'll bring it in terms of a. So p is 15a squared plus q is 54a squared, which is equals to 276. Adding 54 and 15, we'll get 69a squared is equal to 276. Now we'll divide 276 by 69. So a squared would be 276 divided by 69, which is equals to 4. So a squared is 4. Taking the square root of 4, we'll get plus minus 2 for the values of a. In question 3, part A, it says to express 4x square minus 24x plus p in the form a into x plus b whole squared plus c, where a and b are integers and c is to be given in terms of the constant p. Now, to convert it to the form, we'll compare the two forms. So expanding a into x plus b whole squared, we'll get x squared plus 2bx plus b squared plus c. Multiplying with a, we'll get ax squared plus 2abx plus ab squared plus c. And this is equals to 24x squared minus 24x plus p. Now comparing the two forms, we have x squared coefficient as 4 on the left hand side and a on the right hand side. So a will be equals to 4. The coefficient of x on the left hand side is minus 24, and on the right hand side is 2ab. So 2ab will be equals to minus 24. As a is already known, which is 4, so 2 times 4 will be 8. So 8p is equals to minus 24. B will be equals to minus 3. Finally, to find c, we'll compare the constant terms. So on the left hand side, it's p, and on the right hand side, it's ab squared plus c. So we'll put them equal to each other. Substituting the values of a and b, a is 4 and b is -3. So we'll whole square it plus c equals to p. So this will become 9 times 4, 36 plus c equals to p. So c will be equals to p minus 36. Now in part B, it is saying hence or otherwise find the set of values of p for which the equation has no real roots. Now to find the set of values of p for which it has no real roots, we can simply use the discriminant, which is b squared minus 4ac. And as it has no real roots, we'll put it less than 0. Now b is -24, so we can use -24 whole squared minus 4 into the value of c is p over here, less than 0. Taking 4 and p on the right hand side to make p positive, we will get 24 squared is less than 16p. So this is 24 squared is less than 16p. Dividing 24 squared by 16 greater than p. So p will be greater than 24 squared upon 16. So dividing 24 squared by 16, this will become 36 greater than p. So the values of p will be greater than 36. In question 4, we have to solve the equation 8x power 6 plus 215x cube minus 27 equals to 0. Now we can try and factorize this equation directly, or we can use a substitution. Now we can see that this is x cube and x to the power 6. So if, let's say, in place of x cube we use y, which is equals to x cube. So x to the power 6 will be equals to, well, if we whole square this will become x to the power 6. So x power 6 will be equals to y squared. So we'll have a quadratic equation of the form 8y squared plus 215y minus 27 equals to 0. Now we can apply the quadratic formula. So we can say y equals to minus b. So minus b will be minus 215 plus minus square root of b squared minus 4ac. So b is 215 whole squared minus 4 into a is 8 and c is minus 27 divided by 2a. So this will be 2 into 8. Substituting the values in the square root in the calculator. So when we write 215 whole square minus 4 into 8 into 27, this will become 47089. Taking the square root of 47089, we'll get 215 plus minus. So the square root of 47089 is 217 divided by 16. So y will be equals to minus 215 plus 217. So that will be 2 upon 16, and y will be equals to minus 215 minus 217, which will be equals to 432 divided by 16. That will be minus 27. So we have the two values of y as 1 upon 8 and minus 27. Now we had the substitution y is equals to x cube. So in place of y, if we substitute 1 upon 8 is equals to x cube, the value of x will be 1 upon 2. And in place of y, if we substitute minus 27, so this will be minus 27 is equals to x cube. Taking the cube root on both the sides, we'll get x is equals to minus 3. So the two values of x will be equals to minus 3 and x will be equals to 1 upon 2. In question 5, the diagram shows a curve with the equation y equals to 10x to the power half minus 5 upon 2x to the power 3 upon 2. The curve meets the x-axis at the point 0, 0 and 4, 0. We have to find the area of the shaded region. So to find the area of the shaded region, first we'll have to integrate the equation and put in the limits. So the limits in this case are 4 and 0. And the equation is 10x to the power half minus 5 upon 2x to the power 3 upon 2. So integrating 10x to the power half will increase the power by 1. So adding 1 upon 2 plus 1, that will become 3 upon 2. And we'll divide that by the new power, which is 3 upon 2 minus 5 upon 2. Increasing 3 upon 2 by 1, that will become 5 upon 2. And we'll divide by 5 upon 2 in the denominator. So this 2 and 2 will cancel. 5 divided by 5 will also cancel. So we can write the equation as 20. So 2 will go and multiply with 10. So this will become 20 upon 3 x to the power 3 upon 2 minus x to the power 5 upon 2. Now once we have integrated, now we can put in the limits 4 and 0. So substituting 4 in place of x, we'll get 20 upon 3, 4 to the power 3 upon 2 minus 4 to the power 5 upon 2. Then substituting the lower limit, which is x equals to 0. So that will be 20 upon 3 into 0 minus 0 to the power 5 upon 2, which will be 0. So 4 to the power 3 upon 2, we can substitute this in the calculator, or if we even do it without a calculator, so square root of 4 is 2, 2 cube will be 8, so this will be 20 upon 3 into 8 minus square root of 4 is 2, and 2 to the power 5 will be 32. So 160 upon 3, so this will become 160 upon 3 minus 32. Simplifying this, the final answer will be 64 upon 3, as if we take the LCM and multiply by 3, this will be 160 minus 96. So the final answer will be 64 upon 3 for the area of the shaded region. In question 6, the diagram shows a sector OAB of a circle center O, angle AOB is theta, and OP equals to AP equals to x. We have to show that the arc length AB is 2x theta cos theta. Now we know that the formula for arc length is S is equals to R theta. So we can take R as OA or OB. So to find the length of OA, we can use a triangle. As this is an isosceles triangle, we can divide into two equal parts by making a line from P, which will be a right angle. So the length of OP will be equals to, so as this is theta, let's call this length as Y. So cos theta will be equals to Y upon, so adjacent upon hypotenuse, so this will be X. So Y will be is equals to X cos theta. So the total length will be, so the length of OA will be equals to 2x cos theta. Now putting it back into the formula, S equals to R theta, it will become R is 2x cos theta multiplied by theta. So this was expression they wanted us to prove. So we have 2x theta cos theta. Now mistake that students can make in this question is, let's say if they apply sine or cosine rule. So if this is x and this is x, it means this angle will be theta and this angle will be pi minus 2 theta. So when we apply sine rule for OA, it will be OA upon sine of pi minus 2 theta equals to x upon sine theta. Now we know the identity of sine of pi minus theta. So the identity for sine is sine theta is equals to sine of 180 minus theta, which is also equals to 2 pi. So we can write it as OA upon, this will become sine of 2 theta is equals to x upon sine theta. OA will become x sine of 2 theta upon sine theta. Now the identity to convert sine 2 theta to cos theta is not done in AS level, it is only done in A2 level. So even though the identity is given at the back as sine 2 theta is 2 sine theta cos theta, upon sine theta, it will cancel, sine and sine will cancel, and we'll again get 2x cos theta, which was the length of OA. But rather than using this, it is easier if we just simply make a triangle, a right angle triangle, and find the half length of OA and then multiplying it by 2. In part B, we have to find the area of the shaded region ABB in terms of x and theta. So to find the area of the shaded region, first we'll find the area of sector. So the area of sector is given by the formula half r squared theta. So in place of r, we have 2x cos theta. So this will be 2x cos theta. So whole squared multiplied by theta. We can simplify it to write it as 4x square cos square theta upon 2 multiplied by theta. So this will become 2x square cos square theta multiplied by theta. To find the area of the triangle, we can use the sine, the area of a triangle will be given by half AB sine C. So area of triangle will be equals to half AB sine of C. So we can take these two lengths, OA and OP, and the angle as theta. So half into one of the lengths is x, and OA is 2x cos theta multiplied by sine theta. To find the area of the shaded region, we'll just simply subtract the two answers of the sector and the triangle. So the shaded region will have an area of 2x square theta cos square theta minus, so this will become 2 and 2 will cancel. This will become 2 sine theta cos theta times x. So we can leave our answer like this, and this 2 sine theta cos theta can also be written as sine 2 theta, which is an identity we will not be doing in AS level. However, even if you leave your answer in this form, this will be correct. In question 7, part 1, it says that by first expanding cos theta plus sine theta, we have to find the three solutions of the equation cos theta plus sine theta whole square equals to 1. Now, expanding cos plus sine whole square, I'll be using C and S in place of cos theta and sine theta. So expanding cos plus sine whole square, we'll get cos square plus 2 sine cos plus sine squared equals to 1. So now we can see that cos squared plus sine squared, we can use the identity as sine squared plus cos squared is equals to 1. So we can write it as 2 sine cos. Well, there is no square over here. So this will be 2 sine cos plus 2 equals to 1. And 2 sine cos, and this is a 1 over here. So this will be 1. So 1 minus 1 will become a 0. So we can write it as sine theta equals to 0 and cos theta equals to 0. Now taking sine inverse of 0, we'll get one of the answers as 0, and cos inverse of 0, the answer will be pi upon 2. Now from 0 to 180, as the limit is from 0 till pi, we know that if one of the answers for sine theta equals to is 0, another answer will be sine of pi, as sine of pi is also 0. So the three values of theta will be 0, pi upon 2, and pi. In part 2, we have to verify that the only solution of the equation cos theta plus sine theta is equals to 1 are 0 and 1 upon 2 pi. So to verify this, we'll substitute first of all 0 in place of theta. So we'll get cos 0 plus sine 0, and it should be equals to 1. So cos 0 is 1 and sine 0 is 0. So as it is equals to 1, it is one of the solutions. Substituting sine 1 upon 2 pi in place of theta, we'll get cos 1 upon 2 pi plus sine 1 upon 2 pi. And as cos 1 upon 2 pi is 0 and sine 1 upon 2 pi is 1, so this will also be equals to 1. So it is verified these are the two solutions. Now taking sine theta is equals to pi, we'll get cos of pi plus sine of pi equals to 1. Cos of pi is minus 1 and sine of pi is 0. So as minus 1 cannot be equals to 1, it means that pi is not a solution, which means that the only two solutions are 0 and 1 upon 2 pi. In part B, we have to prove the given identity. So we'll start proving the identity by first taking the LCM. The LCM will become cos minus sine and cos plus sine. So this will be cos plus sine and cos minus sine. This sine will multiply by cos minus sine, and 1 minus cos will multiply by cos plus sine. Opening up the brackets, we'll get sine cos minus sine squared, and then 1 multiplied by cos will be cos into 1 plus sine will be sine minus cos squared minus sine cos divided by the denominator. We can convert it using the identity a squared minus b squared equals to a minus b a plus b. So we can write it as cos squared minus sine squared. So sine cos minus sine cos will cancel out. So we'll get cos plus sine minus sine squared minus cos squared, and as in the denominator we needed a term in sine squared, so we'll replace cos squared with the identity cos squared is equals to 1 minus sine squared. Now as we needed 1 in the numerator, we can take the negative sign common and write sine square plus cos square upon 1 minus 2 sine squared, as sine square plus cos squared is equals to 1. So we can write this as cos plus sine minus 1 upon 1 minus 2 sine squared, which was the identity that we had to prove. Now in part C, we have to use the results of A part 2 and B part to solve this given equation. Now this was the identity that we proved, which was cos plus sine minus 1 upon 1 minus 2 sine squared is equals to 2 into cos plus sine minus 1. Now from the previous part, we already know that cos plus sine minus 1 was equal. So we know that cos plus sine, and if you bring the 1 on this side, this will be equal to 0. So we can put a 0 over here as well, or we can simply cross multiply. So this will become cos plus sine minus 1 is equals to 2 cos plus 2 sine minus 1, and this is multiplying by 1 minus 2 sine squared. Opening up the bracket, we will get cos plus sine minus 1 is equals to, so 2 cos into 1 will become 2 cos, 2 sine into 1 will be 2 sine, minus 1 into 1, this will become a minus 1. And 2 cos plus 2 sine, so this would have been a minus 2. So this will become a minus 2. And then multiplying 2 cos by minus 2 sine square, this will become a minus 4 sine square cos. 2 sine times minus 2 sine square will become minus 4 sine cube. And 2 sine minus 2 into minus 2 sine square will become a plus 4 sine squared. Now to simplify this, we'll bring the cos plus sine plus 1 on the right hand side. So, and the negative terms of minus 4 sine squared cos minus 4 sine cube and 4 sine square on the left hand side. So we'll write it as 4 sine square cos plus 4 sine cube minus 4 sine squared is equals to 2 cos plus 2 sine minus 2, and this will become a minus. So this was a minus, so this will become a minus cos minus sine plus 1. Now taking 4 sine squared common over here, we'll get, so this will become a cos plus sine minus 1. So 2 cos minus cos will be a cos, 2 sine minus sine will be a plus sine, and minus 2 plus 1 will be a minus 1. So we can see that cos plus sine minus 1 will cancel with cos plus sine minus 1. So if we cancel this out, this will be 4 sine squared equals to 1. So sine squared will be equals to 1 upon 4, or sine theta will be equals to 1 upon 2. Now taking sine inverse of 1 upon 2, we'll get one of the answers. The basic angle is pi upon 6. So this will become pi upon 6, and we'll make a basic angle over here, which is also pi upon 6. So the two values of theta will be pi upon 6, and then this will be pi minus pi upon 6, which is 5 pi upon 6. Now, as we had to also use the answer from A part 2, we know that cos plus sine minus 1 was equals to 0. So if in place of cos plus sine minus 1, we had replaced the 0 over here, we would have been left with cos plus sine minus 1 equals to 0. So one of the other solutions would have been cos plus sine minus 1 equals to 0. As if we replace this with a 0, cross multiplying over here, it would have been a 0 altogether. So cos plus sine would have been equals to 1. And from the previous part, we know that the solution for cos plus sine is equals to 1 is 0 and half pi. So we'll add the two solutions as well, which are 0 and 1 upon 2 pi. So the theta will have four solutions: pi upon 6, 5 pi upon 6, 0, and 1 upon 2 pi. In question 8, the diagram shows the graph of y equals to f of x, where the function f is defined by f is equals to 3 plus 2 sine 1 upon 4x for x 0 to 2 pi. On the diagram above, we have to sketch the graph of y equals to f inverse of x. Now, what we need to know is that f of x and f inverse of x are reflections of one another in the line y equals to x. So to make the line y equals to x, we'll make points at 1 upon 2 pi, 1 upon 2 pi. We can make them at 3 upon 2 pi and 3 upon 2 pi and 0 and 0. So we'll make a line joining these these 3 points. So this will be the line of reflection through which y equals to f of x will be reflected onto y equals to f inverse of x. So to reflect this now, we can see that this point will reflect and come up over here. This point will remain as it is. This point on the curve will be reflected on the in the line y equals to x, and it will be over here now. So now we have 3 points, 1, 2, and 3. We can join them to make a curve, which will be the graph of y equals to f inverse of x. So this will be y equals to f inverse of x. In part B, we have to find an expression for f inverse of x. Now to find an expression in the first part, we will replace f of x with y. So this will become 3 plus 2 sine 1 upon 4x. Now in place of y, we'll put x, and in place of x, we'll put y. So this will become 3 sine of 1 upon 4y. Taking 3 on the other side, this will become x minus 3, and dividing by 2, this will become x minus 3 upon 2 equals to sine of 1 upon 4y. Now taking sine inverse, so this will become 1 upon 4y is equals to sine inverse of x minus 3 upon 2. So this will become sine inverse of x minus 3 upon 2. And finally, we'll multiply the answer by 4 to get y. So y will be equals to 4 sine inverse of x minus 3 upon 2. We can finally write our answer as f inverse of x is equals to 4 sine inverse of x minus 3 upon 2. In part C, says that the diagram above shows a part of the curve of the graph of the function g of x, 3 plus 2 sine 1 upon 4x, from minus 2 pi to 2 pi. We have to complete the sketch of the graph and explain whether the graph has an inverse. Now to complete the sketch, we'll just substitute values of x into the function. So we'll take values of minus 1 upon 2 pi, minus 3 upon 2 pi and 2 pi. And the values of y we get, we plot them to make a graph. So when we take x equals to minus 1 upon 2 pi and substitute this into the function 3 plus 2 sine, so we'll write it as 3 plus 2 sine of 1 upon 4 multiplied by minus 1 upon 2 pi. Substituting this in the calculator, the value we'll get is 2.617. So 2.617 is over here will be, so this is 3.142 upon 2 and this is 3.142. So this point will be somewhere over here. So this is 3.142 and the value is 2.6. So it will be over here. Substituting x equals to minus pi in this equation, we'll get 3 plus 2 sine of 1 upon 4 into pi. So this will be a negative pi. So substituting this in the calculator, the value will be 2.292. Now 3.142 divided by 2, just to make it clear, this is in decimal, this is 1.571. This value is pi, which is 3.142. So let's say this is 3.142 plus 1.571 divided by 2. This center point is 2.35. So this value will be positive 2.35. So 2.292 will be below 2.35. So this point will be up here. And at negative 1 upon 2 pi, we got 2.6. So it will be a bit above 2.35. When we substitute minus 3 upon 2 pi into the equation, so substituting x equals to minus 3 upon 2 pi, we'll write it as 3 plus 2 sine of 1 upon 4 into minus 3 upon 2 pi. Substituting this in the calculator, the value will be 2.076. So at minus 3 upon 2 pi, it is minus 2.076. So it will be somewhere above 2.292. So it will be just above the line. And substituting x equals to minus 2 pi into the equation, we'll get 3 plus 2 sine of 1 upon 4 into minus 2 pi. So when you substitute this, you will get a value of 2. So at minus 2 pi, the value will be 2. So we'll complete the graph, which will look somewhat like this. Now it also asks whether it is also asking us to explain whether the function g has an inverse. So as we can see that the graph is a one-to-one function. So we'll say yes, as it is a one-to-one function. In part D, it is asking us to describe a sequence of transformations which will combine to transform y equals to sine of x onto the graph of y equals to f of x. So we had y equals to sine of x, and we have to transform it to y equals to f of x, which was 3 plus 2 sine of 1 upon 4x. So as we have to describe three transformations, we'll go step by step. We see that sine of x has become sine of 1 upon 4x. Now this change basically represents a stretch in the in the x direction, and as it is 1 over 4 up here, it means that the scale factor will be equals to 4. So after a stretch in the x direction and a scale factor of 4, y equals to sine of x will become y equals to sine of 1 upon 4x. Now applying a stretch in the y direction of 2 units. So now applying a stretch in the y direction and keeping the scale factor 2, this equation will become y equals to 2 sine of 1 upon 4x. And finally, as it is a plus 3, which means it has moved 3 units in the y direction. So we'll say finally we'll translate. So there will be a translation of, so there is no movement in the x direction. We'll just write translation of 0 and 3. And that will be a final answer. Now, if we perform these operations in any different order, we'll not get the same result. So we'll have to give it step by step. In the first step, it will be a stretch in the x direction. In step 2, it will be a stretch in the y direction. And then finally, we'll have translation of 0 and 3. In question 9, the second term of a geometric progression is 16 and the sum to infinity is 100. We have to find the two possible values of the first term. Now we know that the nth term is given by ar to the power n minus 1. As the second term is 16, we'll write 16 is equals to ar and 2 minus 1 will be 1. The sum to infinity is 100, as the formula is a upon 1 minus r. So we'll write 100 is equals to a upon 1 minus r. So now we have two equations and two variables a and r. So from the second equation, we can say that a is equals to 100 into 1 minus r. Substituting this in the first equation, we'll get 16 is equals to a into, in place of in place of a, we will write 100 into 1 minus r times r. So this will become 100 r minus 100 r squared equals to 16. Taking the r squared on the left hand side to make it positive, we'll get 100 r squared minus 100 r plus 16 equals to 0. Dividing it by 4 to make it simple, the equation will become 25 r squared minus 25 r plus 4 equals to 0. Now we can factorize it by middle term breaking. So this will become minus 20r minus 5r plus 4 equals to 0. Taking 5r common from over here, we'll get 5r minus 4, and taking 1 common, we'll get 5r minus 4 equals to 0. Finally, we'll write this as 5r minus 1 and 5r minus 4 equals to 0. The two values of r will be r equals to 1 upon 5 and r equals to 4 upon 5. Now, once we have the values of r, we can find the value of a using the equation 16 equals to ar. As we have to find the two possible values, so as ar was equals to 16, if in place of r we put 1 upon 5, the value of a will be equals to 80. And if in place of r we substituted with 4 upon 5 equals to 16, so this will be 16 times 5, 80 upon 4. So the other value of a will be equals to 20. In part B, it is saying that show that the nth term of one of the two possible geometric progressions. Now, as we had two values of a, so for the nth term, one of the formula will be 20, and for 20 we took the common, when we got a as 20, the common ratio was 4 upon 5. The formula will be 4 upon 5 to the power n minus 1. and the other geometric progression, as the first term was 80, the common ratio was taken as 1 upon 5, so this will be 1 upon 5 to the power n minus 1. Now it is saying that we have to show that the nth term of one of the two possible geometric progressions is equal to 4n minus 2 multiplied by the nth term of the other geometric progression. So what we have to do is we have to multiply one of these expressions with 4n minus 2 and prove that it is equal to the other nth term. So let's start with multiplying 20 into 4 upon 5 to the power n minus 1, and we'll multiply it by 4 into the power minus 2. So opening this bracket up, 4n minus 1 will become 4n into 4 to the power minus 1, and 5 will become 5n into 5 to the power minus 1 multiplied by 4n into 4 to the power minus 2. So we can simplify this. This 4 will become a denominator. So we can bring this 4 and 4 square in the denominator. So this will become 20 upon, we can write this as 4 into 4 squared. In the numerator, we'll have 4n and 4n. And 5 power n and 5 power minus 1 will remain as it is. Now, for the other term, it would have been 80 upon, so this would have remained 1, 5n into 5 power minus 1. So simplifying this would have become 80, and bringing 5 power minus 1 in the numerator, this would have been 5 upon 5 to the power n. So we can see that these two terms are not equal. So now in the next step, we'll multiply this expression and see if we can get the expression for the nth term where a was 20. Now multiplying this other nth term, 80 into 1 upon 5 to the power n minus 1, multiplying it by 4n to the power minus 2, we'll get 80 into 1 upon 5n into 5 power minus 1, multiplied by 4n into 4 power minus 2. So keeping 4 power n in the numerator, will bring 4 power minus 2 in the denominator. This will become 80 upon 16. And we can leave 4 power n and 5 power n into 5 power minus 1 as it is. As 80 upon 16 is 5, so this will be 5 into 4 power n upon 5 power n into 5 power minus 1. So the nth term with 820 and r was 4 upon 5. So that will become 20 into 4 upon 5 to the power n minus 1. Opening the bracket up, we'll get 20 into 4n into 4 power minus 1 upon 5n into 5 power minus 1. Now 4 power minus 1 will come in the denominator. That will become a 20 upon 4 into 4n, and the denominator will be 5n into 5 power minus 1. So 4 and 20 will cancel out to become 5. So we'll get 5 into 4 power n divided by 5 into 5 power minus 1, which is now equal to the term when we multiplied 80 by 4n minus 2. So multiplying this term where a was 20 by 4n minus 2 was not equal to multiplying 80 by was not equal to the term with 80 as a and r as 1 upon 5. However, when you multiplied the other term where a was 80 and r was 1 upon 5 with 4n minus 2, we can see that it was equal to the term where a was 20 and r was 4 upon 5. In question 10, the equation of a circle is given as x minus a whole squared plus y minus 3 whole squared equals to 20. The line y equals to half x plus 6 is a tangent to the circle at the point P. We have to show that one possible value of a is 4, and we have to find the other possible value. Now, as the line is a tangent, it means it is intersecting the circle at one point. And as we have an unknown constant and it will be a quadratic equation, we'll be using b squared minus 4ac equals to 0, as there is only one point of intersection. Now solving the two equations simultaneously, we'll get x minus a whole squared, and in place of y, we'll substitute half x plus 6. So this will become half x plus 6 minus 3 whole squared equals to 20. So this will be x minus a whole squared plus, so this will be half x plus 3 whole squared equals to 20. Now expanding both of these, we'll get x squared minus 2ax plus a squared plus 1 upon 4x squared plus 2ab. So that will be 2 into half x, which will be x into 3. So this will be a 3x plus 9 is equals to 20. Taking the LCM on the left hand side, so this will become 4x squared minus 8ax plus 4a squared plus x squared plus 12x plus 9 plus 36 upon 4. So the common denominator is 4 up here equals to 20. Cross multiplying and simplifying on the left hand side, we'll get 4x squared plus x squared as 5x squared. We'll make so the terms in x are minus 8ax and plus 12ax, 12x, and the constant term is 4a squared plus 36 equals to 80. Bringing the 80 on the left hand side, we'll get 5x squared minus 8ax plus 12x plus 4a squared, and 36 minus 80 will be a negative 44 equals to 0. Now, as we have simplified the expression, we can first take x common over here. So if we take x common, this will become a minus 8a plus 12 plus 4a squared minus 44. So the coefficient of x squared is 5. So a will be equals to 5. The coefficient of x is minus 8a plus 12. And the constant term is c. So that will be 4a squared minus 44. Now taking b squared minus 4ac. So b squared will be minus 8a plus 12. We can write it as 12 minus 8a whole squared minus 4 into 5 into 4a squared minus 44, and we'll put it equals to 0, as if it is a tangent, the discriminant b squared minus 4ac will be equals to 0. So expanding 12 minus 8a whole squared, this will become 144 minus 2 into 12, 24 into 8 is 192a plus 64a squared. So this will be 4 5 is 20, 20 times 4 is 80a squared, and then 4 5 times is 20, and then 20 times 44 will be 880. So this will become a minus, this will become a plus 880 equals to 0. So simplifying this expression, we'll get, so this was a 64a squared. So 64a squared minus 80a squared will be a minus 16a squared minus 192a, and 144 plus 880 is equals to 1024. We can make the square term positive to write this equation as 16a squared plus 192a minus 1024. Now we can substitute this equation as it is in the calculator, or if we divide this equation by 16, so this will become a squared. 192 divided by 16 is equals to 12, so this will become a 12 minus 1024 divided by 1 divided by 16 is equals to 64. So this will be a squared plus 12a minus 64 equals to 0. When you factorize this, this will become a plus 16 and a minus 4 equals to 0. So one of the values of a is equals to 4, as we had to prove in the expression, and the other value will be a equals to minus 16. In part B, for a equals to 4, we have to find the equation of the normal to the circle at P. Now, the equation of the circle was x minus a whole squared plus y minus 3 equals to 20. So in place of a, we'll write 4. So this will become x minus 4 whole squared plus y minus 3 whole squared equals to 20. As we have to find the equation of the normal to the circle at P. So let's say if we have a circle, this was the tangent up here and this was the point P. So this will be the normal for which we have to find the equation. Now we already have the point on the normal, which is 4 and 3, which is the center point. So this point is 4 comma 3. Now to find the equation, the gradient of the normal, we have the gradient of the tangent from our original equation, which was 1 upon 2. So as the gradient of the tangent was 1 upon 2, the gradient of the normal will be the negative reciprocal, which is minus 2. So now we can write the equation as using the formula y minus y1 is equals to m into x minus x1. So the center point is 4 comma 3. So we'll use y1 as 3. So this will be y minus 3 is equals to minus 2 into x minus 4. Simplifying this, we'll get y minus 3 is equals to minus 2x plus 8. So the final equation will be y equals to minus 2x plus 8 plus 3, which is equals to y is equals to minus 2x plus 11. In part C, for equals to 4, we have to find the equations of the two tangents to the circle which are parallel to the normal found in B. Now, the equation of the normal found in B was y equals to minus 2x plus 11. It means that the gradient of the normal which are parallel, of the tangents which are parallel to the normal, will also be minus 2. So we can say that the equation will be y equals to minus 2x plus, as the c is unknown, so we'll write it as it is. The equation of the circle was x minus 4 whole squared plus y minus 3 whole squared equals to 20. Now to find the value of c, we'll substitute y equals to minus 2x plus c into this equation of the circle, simplify it, and then apply b squared minus 4ac to find the value of c, as the tangents are intersecting the circle at one point. So substituting y equals to minus 2x plus c, in place of y, we'll get minus 2x plus c minus 3 whole squared equals to 20. Now to expand minus 2x plus c minus 3, we can write it as minus 2x plus c minus 3 multiplied by minus 2x plus c minus 3. So expanding this, we'll get minus 2x into minus 2x will become a plus 4x squared. Minus 2x into c will become a minus 2xc. Minus 2x into minus 3 will become a plus 6x. Then multiplying c by minus 2x, we'll get a minus 2xc. C multiplied by c will become a plus c squared. And then c into minus 3 will become a minus 3c. Then multiplying this minus 3 by minus 2x, we'll get a plus 6x. Then multiplying minus 3 by plus c, will get a minus 3c. And then minus 3 times minus 3 will become a plus 9. Simplifying this equation, we'll get 4x squared. Minus 2xc will become a minus 4xc. 6x plus 6x will become 12x. And then we'll have plus c squared. Minus 3c will be minus 6c and plus 9. So the expansion of x minus 4 whole squared will be x squared minus 8x plus 16. And in place of minus 2x plus c minus 3 whole squared, we can write 4x squared minus 4xc plus 12x plus c squared minus 6c plus 9 equals to 20. Simplifying this, we'll get x squared plus 4x squared as 5x squared. Minus 8x plus 12x is a 4x. So this will become a plus 4x. And then the other x term is minus 4xc. So this will be minus 4xc. And then the constant term is plus c squared minus 6c. 16 plus 9 is a 25. So this will become a plus 25 minus 20 equals to 0. So this will become 5x squared plus 4x minus 4xc plus c squared minus 6x plus 5 equals to 0. So now, before applying b squared minus 4ac, we'll take the x common over here to get 4 minus 4c. And this will be plus c squared minus 6x plus 5 equals to 0. So we'll have a is equals to 5, b is equals to 4 minus 4c, and c is equals to c squared minus 6c plus 5. So this is a c, not a x up here. Now applying b squared minus 4ac, this will become 4 minus 4c whole squared minus 4 into 5 into c squared minus 6c plus 5 equals to 0. Expanding 4 minus 4c whole squared, we'll get 16 minus 4 times 4 is 16 times 2 will become 32c plus 16c squared. Multiplying 4 by 5 will get 20. 20 times c squared will be 20c squared. 20 times 6 will be a plus 120c, and minus 20 into minus plus 5 will be a minus 100, which will become equals to 0. Now simplifying this, we'll get 16c squared, and then we have minus 20c squared, so that will become 16c squared minus 20c squared is minus 4c squared. minus 32c, and the other term is plus 120c, so that will become a plus 88c, and 16 minus 100 will become minus 84 equals to 0. We can make the squared term positive to write it as 4c squared minus 88c plus 84 equals to 0. Now to find the value of c, we will first divide by 4 to write the equation as c squared minus 22c plus 21 equals to 0. Factorizing this, we will get c minus 21 and c minus 1 equals to 0. So the two values of c is equals to 21 and c is equals to positive 1. So the two equations of tangents will become y equals to minus 2x plus 21 and y equals to minus 2x plus 1. In question 11, the equation of a curve is y equals to k square root of 4x plus 1 minus x plus 5, where k is a positive constant. We have to find the dy dx. So to find the dy dx, this will be written as k into 4x plus 1 to the power of 1 upon 2 minus x plus 5. So finding the dy dx, will multiply 1 upon 2 by k. So this will become 1 upon 2k. 4x plus 1, 1 upon 2 minus 1 will become minus 1 upon 2. Derivative of x is minus 1. And we'll also multiply the derivative of 4x plus 1, which is 4. So we'll multiply the 4 over here. And the derivative of 5 will be 0. So we can write this equation as 2k upon 4x plus 1 minus 1. So the dy dx will be equals to 2k upon 4x square root of 4x plus 1 minus 1. And we can first write this equation as y. So dy dx will be 2k upon square root of 4x plus 1 minus 1. We have to find the x coordinate of the stationary point in terms of k. Now the stationary point means that the dy dx will be equals to 0. So we'll write it as 0 equals to 2k upon square root of 4x plus 1 minus 1. Taking the 1 on the other side, we will get 2k upon square root of 4x plus 1 equals to 1. Cross multiplying, we'll get 2k is equals to square root of 4x plus 1. Now to find the x coordinate in terms of k, we'll first take the whole square on both the sides. So whole square in both the sides, we'll get 4k squared is equals to 4x plus 1. Now making x our subject, we'll get x is equals to 4k squared minus 1 divided by 4. In part C, it says that given that k is equals to 10.5, find the equation of the normal to the curve at the point where the tangent to the curve makes an angle of tan inverse of 2 with the positive x-axis. Now, in the first step, we have to first understand that if we have a curve like this, and let's say this is the x and the y-axis, the tangent is making an angle of tan inverse of 2 with the x-axis. So this is the angle tan inverse of 2. Now we know that tan theta or tan x is equals to opposite over adjacent. So tan inverse of 2 means this would have been 2 upon 1, or the y value was 2 and this was 1. So now we can deduce that the gradient would have been, which is y, the change of y upon change of x. So the gradient of the tangent was 2. It means that the gradient of the normal will be is equals to negative 1 upon 2. Now, as we know that the gradient of the tangent is 2, we can now find the value of x to form the equation of the normal. So dy dx we know was given as 2k upon square root of 4x plus 1 minus k. So dy dx is equals to 2k upon square root of 4x plus 1 minus 1. In place of dy dx, we'll write 2 is equals to 2 and k value is 10.5. So this will be 10.5 upon square root of 4x plus 1 minus 1. Taking the 1 on the other side, we'll get 3 is equals to 21 upon square root of 4x plus 1. Cross multiplying, we'll get 3 square root of 4x plus 1 equals to 21. To find the value of x, we'll whole square both the sides. So whole squaring 3 into square root of 4x plus 1 and square root of 21, square of 21, we'll get 9 into 4x plus 1 is equals to 21 whole squared is 441. 441 divided by 9 is 49. So 4x plus 1 will be equals to 49. So 4x is equals to 48 and x will be equals to 12. Now, once we have the value of x, we can substitute this value of x in the equation to find the value of y. As y was given as y equals to k square root of 4x plus 1. So we can write it as 10.5 into square root of 4 x plus 1. So x is 12 plus 1 minus x plus 5. So in place of x, again we'll put 12 over here plus 5. Substituting this value in the calculator, the y value will come out to be 66.5. So we have the point with on the line which will be x equals to 12 and y equals to 66.5. So this point at the tangent, x is 12 and y 66.5. We have the gradient which is minus 1 upon 2. To form the equation, we'll write it as y minus y1, which is 66.5, is equals to minus 1 upon 2, which is the gradient, into x minus x1, which is 12. Now we can leave the equation as it is, or if you want to simplify, we can write it as 2y minus 66.5 times 2 is 133, is equals to minus x plus 12. So we can write the final equation as 2y is equals to minus x plus 12 plus 133, which is equals to 2y is equals to minus x plus 145, which will be the equation of the normal.